Good afternoon, Eric. It's so good to see you again.
Always a pleasure.
Eric, I have a question for you today, or something I'd like to hear you tell me about, which is, can you give me a sort of flyover view of the life cycle of a star from your perspective?
Okay, I will be happy to do that. Now, I need to set the stage for what I'm going to do. Einstein clearly identified that in a four-dimensional structure of the universe, which it must be, um, what happens is around any concentration of mass energy, such as the Earth or the Sun, the space around it compresses inwards. Now, Einstein assumed that space is what I would call a passive element. You can compress it and it becomes compressed. And if you take away what's compressed, it'll expand again. But in the compressed space, an energy gradient, is established. Now, this has caused a lot of consternation because how does an energy gradient come about and what keeps the energy gradient intact? Well, there is a very simple answer to that question, and it is an important answer. It is because of this belief that there is a completely flexible, fluid, continuous space. And space needs to collapse, and then an energy gradient needs to arise. Now, I had proposed a paradigm shift in how we think about the cosmos. There is no basis for believing that such a smooth and continuous space exists. And space could just as well be granular as continuous, as long as the grains are very, very small compared to the stuff that they're associated with. Now, that is absolutely true in the model that I proposed, where it suggests that the grains of space, what I call cosmic nodes, are basically as small as the smallest possible particle in the universe. Now, however, if I am correct, these particles must have significant mass energy. How can they gain significant mass energy? Well, not as three-dimensional objects, and not even as four-dimensional objects, but as six-dimensional objects. They have a very respectable amount of mass energy associated with them. So Newton would have gotten exactly the same results as far as gravity is concerned if he had treated space as being made up of granules rather than being a smooth and continuous material. Now, here, though, if the granules of space collapse, they have mass energy. So the mass energy of the granules is the energy gradient. The collapsed space is in the form of an energy gradient. There are not two events that happen. There is only one. And this explains why everybody who in physics who has been looking for a graviton that, quote, modulates the energy gradient is looking for a ghost. There is no such particle. Now,
they understood the space as being granular they wouldn't be looking for this. They would understand the energy gradient.
The energy gradient is also the space gradient, because space only exists where there is a cosmic node. It would change Newton's perspective of the way gravity works, not at all, because the arithmetic that he is using that assumes space to be continuous, it is absolutely, there is no discernible difference between that and considering it to be granular if there were mathematics to consider the granular model, which there isn't. So we can use the
assumption. This is an assumption that's sort of carried over.
It is an assumption that Newton didn't realize he was making. Yes. But I'm saying if he makes this, his whole theory of space contraction is much simplified. There are no two things of space contracting and an energy gradient going up in the contracted space. The contracted space is both the energy gradient and the space gradient, because space only exists where there is a particle, and a compression of particle creates a gradient just like space would. So you would have no change whatsoever to any of the work that Einstein did. So
let me just make sure I'm with you. So if you let go of the assumption of space being continuous,
right,
you test the concept of space being granular, everything gets resolved.
Not only gets resolved, things that we couldn't resolve before become resolved. One of the reasons people have so much problem understanding general relativity is they don't know where in heaven's name this energy gradient comes from, and nobody can explain it. And there's a very good reason for this, in my opinion. It doesn't exist. Now, we have to start from that premise, but that premise happens immediately as an immediate consequence of a paradigm changing premise that space is not continuous. There are other reasons to believe that it cannot be continuous that I'm not going to go into at this point, but that is a fact.
Okay. Now, how do we connect this to the life cycle of a star? I think that's where you're going now.
That's where I'm going now.
Okay.
So what is happening to a star is there is a huge cloud of helium, and that cloud is being compressed more and more. And the more it's being compressed, the more it attracts other helium. So you get more and more helium being compressed more and more, and this splits into smaller sizes, star-sized blobs. And what happens is these things all become compressed, and for the most part, they get compressed to the point where at the very interior of the star, the pressure is so high that it literally ignites, and it ignites into a fusion reactor. And the stars that we look at, the luminous stars, are all fusion reactors. And what's happening in the fusion reactor is that not only is the hydrogen being compressed into higher and higher density masses.
The helium being compressed.
Actually, the hydrogen being compressed.
Oh, so the hydrogen converts to helium?
To helium, no, correct.
Helium converts to hydrogen.
No, hydrogen. Helium is chemically 4 hydrogen molecules.
Oh, I see. Okay.
But the molecules do not go 4 to 1. There is a little energy left, and that energy is radiated away, and that generates a counter pressure to the pressure of the energy gradient around it.
Okay.
Okay, so you have a process of equilibrium, which in the case of our sun lasts for a little while, about 10 billion years. Now, after 10 billion years, which is a little longer than our life cycle, what is going to happen is there is no more hydrogen to convert into helium, so there's nothing to prevent the pressure from compressing the gas, what's left there. It's even more. And this goes on until, in the case of our sun, it strips the electrons from the atoms, and the free electrons are looking to go into higher and higher energy states as the compression continues. And when you run out of energy states, you have what is called electron degeneracy. The electrons cannot find higher energy states, and that sets up a counter pressure that stops the further contraction. But the sun has, by this point, contracted to the point where each dimension has gone down to 1/10 of what it used to be. In fact, the sun has been almost the exact size of what the Earth is now. The Earth has long since disappeared in all this. Okay, but now you have this. Now, what happens if the star is bigger than our sun? And there is an even higher energy gradient. Well, what happens there is that the energy gradient is enough to overcome this counter pressure of electron degeneracy, and the compression goes on until the interior of the star has been compressed into the smallest, further incompressible matter called neutrons. And we have a neutron star. And a condition of neutron degeneracy sets in, and it prevents further compression of that. And if the energy is even higher, then the gradient is even larger. It finally will compress the neutrons, but the neutrons can't compress into any other three-dimensional matters. They have only one place to go. They skip the dimensionality barrier, and they become six-dimensional Planck masses. And these Planck masses concentrate into what will become the nucleus of a black hole. And the black hole, it will be surrounded by cosmic nodes that can also not be compressed any further. So in other words, a black hole we can simply think of is a concentration of Planck masses that are all compressed into the same one Planck size, which is at the center of a overlapping number of spherical shapes of cosmic nodes, where the cosmic nodes, the radius of the cosmic nodes, is exactly equal to the number of Planck masses. Now, this is an equality that only occurs if you believe in a granular shape, and which nobody has figured out yet, because nobody else seems to believe in that. But if you do believe in this, it becomes what I call the black hole equality, which states that the number of Planck masses in this singularity must equal the number of cosmic nodes in the radius.
Or the circumference.
No, well, in the radius. The radius is the
radius. Oh, okay.
Then the circumference is around there. Now,
okay. It's not the diameter then.
Yeah, exactly. Well, twice the radius is the diameter.
Yeah. Okay.
Okay, now that is what happens. And this is what everybody believed is all of the possibilities, until a couple of months ago, somebody said, you know something, by a strange thing, not a direct observation, we have found a star that is part black hole and part neutron star. How can that be? Now, that's a story unto itself,
yes.
but I can explain that also. But that's going to take another session,
Another day.
another day.
That's great. Eric, thank you so much. I really appreciate your effort.
You are very welcome, and I appreciate you listening to all this.
Well, but specifically your effort to take this information that a lot of people feel is beyond them, esoteric, and to bring it to a place where more of us can just kind of colloquially understand it.
Well, you see, Einstein said something very interesting at one point in his life, and I'm not quoting him precisely, but he says that if we ever find a solution that combines everything in cosmology, we should be able to start with an initial premise and take it through all of its stages by just reasoning.
Yes, yes,
Logical reasoning.
yes.
And that is basically what we are attempting to do. But the thing that was in the way of doing this was this belief in continuity of space-time. There is absolutely no evidence that it exists. In fact, there is some evidence which can be presented that shows it cannot exist. And
also for another day.
And for another day, we will go into that whole premise. There is it's simple in a point, in that sense that we can go through it all without resorting to any mathematics. Although I've pointed out where people need to put mathematical tools to work to understand the values of some of this. But it all becomes rational, logical deductions. So if we can get from these few starting ideas and put this whole seeming jigsaw puzzle of the cosmos into a shape where it can actually be assembled into one complete whole, which right now it cannot.
Yes.
We will have maybe made a small contribution.
Well, there's also that saying about if you couldn't explain it to a 5-year-old, you don't really understand it anyway.
Well,
I feel like I'm your 5-year-old here.
Okay.
Your 5-year-old, which is great.
Okay, my 5-year-old. You are younger than me, but not by that much.
No, give or take 60 years.
Give or take a few decades.
All right, great seeing you, Eric.